We'll now look at section 3.5 and discuss symmetry of functions. There are three types of symmetry that we will look at in this section. The first type of symmetry is symmetry with respect to the y-axis. Our definition says, the graph of a function f has y-axis symmetry, or is symmetric with respect to the y-axis, if f of negative x is equal to f of x for all x in the domain of f. Such functions are called even functions. So there are two things that you need to realize as we work through this definition. One is what the graph is going to look like. If you have a graph that is symmetric with respect to the y-axis, if you note that the y-axis is here, if the graph is symmetric with respect to the y-axis, then that means the left-hand part of the graph and the right-hand part of the graph should be mirror images of each other. In other words, if you were to take a piece of paper with this picture drawn on it and fold the piece of paper so that the crease is along the black line, your two pieces of the graph should come up and meet each other. So it is important to know what the graph looks like if it is symmetric with respect to the y-axis. It is also important to know how you're going to show that you have that type of symmetry. And this is how we do that, by showing that f of negative x is equal to f of x. We also have symmetry with respect to the origin. The graph of a function f has origin symmetry, or is symmetric with respect to the origin, if f of negative x is equal to negative f of x for all x in the domain of f. Such functions are called odd functions. These are a little more difficult to look at a graph and determine whether you have that type of symmetry. And so oftentimes, when we're talking about symmetric with respect to the origin, we fall back on this statement, f of negative x is equal to negative f of x, to prove that a function has this type of symmetry. This slide shows a summary of the three types of symmetry that can be present with equations. We say that an equation in x and y is symmetric with respect to the y-axis if replacing x with negative x results in an equivalent expression. The x-axis, and this one we have not yet talked about, symmetry with respect to the x-axis if replacing y with negative y results in an equivalent equation. And symmetric with respect to the origin if replacing x with negative x and y with negative y results in an equivalent expression. So these are the statements that we will use as we look at some examples. So our example says to sketch the graph of the following relations making use of symmetry. So let's begin with part A. Part A says that we have f of x is equal to 1 over x squared, and we're checking to see what type of symmetry this graph has. So I'm going to go back to my procedure table for just a second. The first one that we could check is the y-axis symmetry, and we find that by replacing x with a negative x. So let's try that. So we're going to replace x with negative x, and we're going to see if we get the same expression. So everywhere in this initial problem where I have an x, I'm now going to put a negative x. And I'm going to simplify. So I have f of negative x is equal to 1 over Now, when I take a negative x and square it, squaring a negative makes it become positive. So we're going to have 1 over x squared. And so if you look at this, what we started with is the same as what we got if we plugged in the negative x. In both cases, we got 1 over x squared. So this proves that we have symmetry with respect to the y-axis. So let's make sure by looking at the graph. So if I were to graph 1 over x squared, I get a graph that looks like this. Remember that y-axis symmetry means that if you note the y-axis, that you have mirror images of your graph on either side. In other words, that the left side and the right side are mirror images of each other. And so this does appear that we have y-axis symmetry. So going back to our problem, let's now look at part B. So for part B, we have g of x is equal to x cubed minus x. And if I graph that function, my graph looks something like this. It does not appear to have symmetry with respect to the y-axis. If I trace out my y-axis, it doesn't appear that I have mirror images on the left and the right. It also does not appear to have symmetry with respect to the x-axis. That would mean that the top part of the graph would be a mirror image of the bottom part of the graph. So my instinct tells me that it might have symmetry with respect to the origin. And so that's what I'm going to check. So we need to replace the x with negative x and the y with negative y and see if we get an equivalent expression. All right, so we are going to replace the x with negative x, and we're going to replace the y with negative y. So let's see what happens. If I replace the x with a negative x, all right, so first of all, let's do this. Let's take this expression, and instead of g of x, just to make things a little easier, let's write it y is equal to, because we know that that g of x does play the role of the y. Okay, so we are going to now come in and we are going to replace the x's with a negative x. So this x will be a negative x to the third, and this x will also be a negative x. And now we're going to replace the y with a negative y. So in place of this y, we're going to put a negative y. All right, so let's look at what happens. We're going to do it one step at a time. So let's deal over here with the negative x to the third. That's going to be negative x to the third. We would have a negative 1 raised to the third, which still keeps the negative out in the front. This subtraction in this negative becomes a positive. And so we end up with negative x cubed plus x is equal to negative y. Now, if we do a little bit of simplifying here, we want to get it as close to the original as possible. So if we were to take this expression and multiply by negative 1, we would get a positive y is equal to a positive x cubed minus x. And we can see that we indeed get exactly what we started with. And so we do have symmetry with respect to the origin because we have this equaling this. All right, so let's move on and let's look at part C. part C is x is equal to y squared. And if I take a quick look at the graph of that function, my instinct tells me that this is symmetric with respect to the x-axis, because if I trace out my x-axis, it appears that the top and the bottom are mirror images of each other. So let's check it in that regard. So if we have symmetry with respect to the x-axis, we want to replace the y with a negative y. So we are going to replace the y with negative y. And so we'll rewrite our equation, and instead of that y, we're going to put a negative y, and then we'll square it. And when we square the negative y, it becomes positive, and then we get y squared. And so you can see that we get right back to where we started, and that confirms that we do have symmetry with respect to the x-axis.